Welcome to this video. This video is on simultaneous equations. In mathematics, when we have simultaneous equations, what we're talking about is solving two or possibly more equations to find a solution from the information that we have. So, first of all, what we're doing here is we're working with simple straight lines. So a line in mathematics, when we graph it, it has the equation y equals mx plus c, where m represents the slope or the gradient of the line and c represents the y-intercept, the y-intercept being the point on the vertical axis where it crosses, the x-axis being the horizontal axis and the y-axis being the vertical axis. So if we can represent our line with the equation, an equation of the form y equals mx plus c, then we have expressed it algebraically. All we need to do is go back to our formula y equals mx plus c and look at the slope, the gradient, and the y-intercept. So, using the 2 points we have, we can calculate the slope. You'll recall from earlier mathematics that the slope, or the gradient, is given by the rise over the run, and so the rise here we can symbolize with this red dashed vertical line, how far the graph rises over a given period, and then the run we can symbolize from this horizontal dashed red line, which shows how far it goes along in the horizontal direction. So we've got the vertical component and the horizontal component. So how do we calculate those? Well, let's look at the elements of each point. So we've got 2 minus 1 and 10, 7. So to calculate the vertical distance, what we want to look at is the vertical component of each point, that being the y component. So in the second point, 10, 7, the y component is 7. And in the first point, 2 minus 1, the y component is minus 1. So to calculate the rise, we subtract y1 from y2, so we have 7 minus minus 1. Now we divide the rise by the run. How far does it run? Well, it runs from the first point, 2 minus 1, the x value is 2, so it runs from x equals 2 to the x value of the second point being 10. So we need to go x2 minus x1, which is 10 minus 2, which gives us the denominator in that expression. So to simplify, we have 7 minus minus 1 is 8. 10 minus 2 is 8. 8 over 8 is 1. This line has a slope of 1, which makes it look like a 45-degree line. In the previous slide, we got up to working out the slope, which was 1. So from y equals mx plus c, we derived y equals x plus c. The next and final step is to work out the y-intercept. Now we can do this by taking any point that sits on the line and plugging it in, the x and y values, to work out c. And because we have 2 points already, we can choose either one of them, 2 minus 1 or 10 and 7. So let's choose 10 and 7. So that tells us that when x is 10, y is equal to 7. That point sits on this line, therefore the equality must hold. Y equals x plus c. So this now becomes 7 is equal to 10 plus c. C is equal to minus 3. And we have our equation. Here's another example. Let's take 2 more points. This time we'll use minus 2, 5 and 8, 0. Now minus 2, 5 means negative 2 units in the positive x direction, so 2 units to the left of the origin horizontally, and 5 units upwards, 5 units in the positive y direction. And 8, 0 means 8 units in the positive x direction and 0 units in the y direction. Now let's drop our vertical dashed red line from minus 2, 5, and let's lay our horizontal dashed red line all the way to 8, 0, and recall that slope is equal to rise over run. So the rise here is the difference between the y component of the first coordinate and the y component of the second. So the y component of the second is 0. The y component of the first is 5. So we have 0 minus 5. And we divide that by the run. The run is the horizontal distance. So that's the difference between the x component, the second coordinate, and the x component of the first. So 8 minus minus 2. So we have 0 minus 5 over 8 minus minus 2, which is minus 5 over 10, which is minus 1/2. So our slope is minus 1/2. So we have y equals minus 1/2 x plus c. Now, to finalize our equation, all we need to do is plug in one of the points. Notice that we have 8, 0. This is an easy one to do because one of the values is 0. So if we plug 8 for the x coordinate, 8 for the x, and 0 for y, we get 0 is equal to minus half times 8 plus c, which gives c minus 4 is 0, which gives c is equal to 4. So we have our equation of our line. Y is equal to minus half x plus 4. And notice when we have a negative slope, it goes down as we move in the positive x direction, as opposed to before, where it went up as we moved in the positive x direction. This time let's consider the two following points. So, minus 4, 2, and 12, 2. So x1, y1 is the point on the left, minus 4, 2, and x2, y2 is the point on the right, 12, 2. So again, let's lay down our red dashed horizontal line to show the span of the distance between those 2 points. But this time we can't lay down the vertical line because those 2 points have no vertical distance between them. So we're looking now at a horizontal line if we run the blue line between those 2 points. So once again, recalling that slope is equal to rise over run, and the equation of slope is given by the difference in the y coordinates. So we have y2 minus y1, which is 2 minus 2 over x2 minus x1, which is 12 minus minus 4. That works out to 0 over 16, which is equal to 0. Now, for the first time, we have a slope of 0. What does that mean? Well, if we now plug that into the equation, our equation is of the form y is equal to mx plus c. M is now 0, so we have y is equal to 0x plus c, which is y is equal to c. Now, c is the y-intercept, and where does this cross? It crosses the y-axis at 2. So our equation in this case becomes y is equal to 2. So whenever we have a horizontal line, its equation is simply y is equal to c, where c is the distance from the origin. So y equals minus 1 is 1 unit below the origin horizontal line. Y is equal to 10 units above the origin. Take the point x1, y1, 6 minus 5, and x2, y2, 6, 7. Now we plant those on our grid, and we notice that they are exactly above and below each other. So let's drop our vertical red line. Notice at this time that we have no horizontal component. So these 2 coordinates have the same horizontal component. Now, the equation of a line is y is equal to mx plus c, where m is the gradient. Recall that slope is equal to rise over run. Now, calculating the slope, that's y2 minus y1, which is 7 minus minus 5, over x2 minus x1, which is 6 minus 6. Working that out, we get 12 over 0. Suddenly, we have dividing by 0, which is undefined. Now, as a line gets steeper and steeper, the gradient increases. So for y equals mx plus c, m gets bigger, 2, 4, 10, 20, as the line gets very steep. As the line gets negatively steeper, the gradient increases negatively, minus 2, minus 4, minus 10, minus 20, and so on, until ultimately we reach a vertical line. So, how do we describe that? Well, notice that the x component's always the same on a vertical line, e.g., this is the line x equals 1. This is line x equals minus 3. This is line x equals 8. So always on a vertical line, the x component is the same as the y component varies. So therefore it makes sense to call it x equals c, where c is the x-intercept. In our case, we have x is equal to 6. Having done that work, let's now take a look at an example of solving simultaneous equations. So let's start with a line here, which we can't see, but which is described by the equation y equals minus 1/3 x plus 1. Well, how do we graph that? Well, we know from before that the slope, m of x, is equal to minus 1/3, which means rise over run. Note that it's negative, so that means for every few units going along, it will actually go down rather than up. And we can see that it's 3 units to the right, 1 unit down. 3 units to the right, negative 1 units up, yeah? Or 1 unit down. That's what negative 1/3 means. So we can drop our vertical red line and we can lay our horizontal red line to see the rise over the run. So if it goes 1 unit down and 3 units along, that's the same as 3 units down and 9 units along. And we know that our y-intercept is the plus c at the end, which is plus 1, so it goes through 0, 1, hitting 1 on the y-axis. So now we have our line. Here it is. Second line we have here is y is equal to 2x minus 6. Now the y-intercept will be minus 6, so it goes through minus 6. And we can see the slope given by 2, which is the m value here, is quite steep. So for 1 unit along, 2 units up. 1 unit along, 2 units up. So we can lay down our horizontal dashed red line and our vertical dashed red line. And we notice that if we go along 1, we go up 2. Therefore, if we go along 6, we would go up 12. So now we have 2 points through which to construct our line, and here it is. Now notice that these 2 lines, because they're not parallel, they cross at a point, and that meeting point appears to be 3, 0. But it's not always apparent graphically, so we're going to solve it algebraically. So let's do that by the following means, and we'll do it by different means in the next example. Y is equal to minus 1/3 x plus 1. Y is equal to 2x minus 6. Let's set those two y's equal. So we have 2x minus 6 is equal to minus 1/3 x plus 1. Going down to the next line, let's get rid of that third by multiplying through on both sides by 3. 6x minus 18 equals minus x plus 3. Now let's bring the x's to one side. So adding x to both sides, we get 7x minus 18 is equal to 3. 7x is 21, x equals 3. Now plugging that value into either of those two equations gives us y is equal to 0. So yes, the point of intersection is 3, 0. Let's have a look at another example. Y equals 2/5 x plus 7 over 5. In this case, m is equal to 2/5. Less than 1, a fractional value, but positive, so it means we are gently rising as we move to the right. C is equal to 7 over 5, so the y-intercept is 7 over 5, a non-integer value. Note though that if we move a little to the left, it appears to intersect at an integer value at minus 1. So if x equals minus 1, what do we get? We get minus 2/5 plus 7/5, which is 5/5, which is 1. So for x equals minus 1, y equals 1. Let's take that as a starting point to plot our slope. Notice that the slope is rise over run, which is 2 over 5. So for 5 units, every 5 units to the right, we go 2 units up. So let's imagine 10 units to the right, then we'll go 4 units up. So we drop our red horizontal line, and then we drop our red vertical line. Now we can plot our line, and there it is. Now, our second equation is y equals minus 2x plus 11. So in this case, m is equal to minus 2, a negative slope and greater than 1. So it's dropping quite rapidly as we move to the right. And c is equal to 11. So it crosses up here, the y-intercept. We know that as we move along 1 unit to the right, we go 2 units down. So 2 units down, 1 unit to the right. So let's try 8 units down. That will give us 4 units to the right. So we drop our horizontal red line and our vertical red line. And we should go through that point there, and there is our equation. Notice that it intersects with the blue line at this point, which looks like 4, 3 graphically, but algebraically we will solve to check if that's the case. So now, unlike the previous slide where we equated the y values, this time we will transform the equations into the form ax plus by equals c, and we'll take a multiple of one and subtract it from the other. Now, y equals 2/5 x plus 7 over 5. If we multiply through by 5, we get 5y is equal to 2x plus 7. And if we bring the x and y terms to the same side, we get 2x minus 5y is equal to minus 7. Now, going back to the second equation, y equals minus 2x plus 11. Having the x and y terms on one side, we get 2x plus y is equal to 11. So those are our two equations. Now, if we subtract the upper one, 2x minus 5y equals minus 7, from the lower one, 2x plus y equals 11, what do we get? We get the following. 2x minus 2x is 0. Y minus 5y is y, plus 5y is 6y. 11 minus 7 is 18. So we get 0 plus 6y equals 18. Or 6y equals 18, or y equals 3. Now we can substitute that into either of the above two equations or the original two equations, all of which will yield x equals 4. So indeed, the solution to this set of simultaneous equations is 4, 3. X equals 4, y equals 3. Thanks very much for watching. I hope this was helpful in giving a concise and clear explanation on the topic. If you enjoyed, please feel free to give a thumbs up and subscribe so that you can see future videos as they come out.